Objective is use tape diagrams to model fractions as division. The essential question is, how can I use tape diagrams to model fractions as division? Take a look at a real-world situation. 8 tons of gravel is equally divided between 4 dump trucks. How much gravel is in one dump truck? Well, as you can see by the equally divided between 4 dump trucks, this would obviously be a division problem. The common error most students have is, do they divide 8 divided by 4 or 4 divided by 8? Let's draw a diagram to see what the division sentence should look like. Always remember, when in doubt, draw it out. Now let's take a look. So let's start by drawing the equal sections that you're dividing the whole number into. In our problem, we're dividing 8 tons of gravel into 4 trucks. So you can see our tape diagram is sectioned off into 4 equal pieces. Now we're going to label our total amount that we're dividing into the 4 trucks, which in this problem happens to be 8 tons. The last thing we're going to label is the amount that we're looking for, which is the amount in each truck. Now that we have the diagram, we can tell that we are going to be dividing 8 tons by 4 trucks. Now below you can see the 4 different types of division problems which we've been working with. The first one is our horizontal format, which we've been using a lot, especially when we're working with fact families. The second one is a fraction, 8/4. But just like we've been doing with our fluency practice, you know 8/4, 4 are going to 8 2 times. And that's what we're going to be focusing on. The last one is the standard algorithm, which is 8 divided by 4. As you can see, just like I talked a minute ago, 8 divided by 4, 4 are going to 8 2 times. So we know that our answer is 2. Now, that what's important when you're working with fractions, but this one here is not fractions, but when we're working with fractions, we want to check our work. We're using the easy problem to start with, just so you can understand the concept. So up here, we can see that our sentence that we started off with was 8 divided by 2 equals 4. So we know with our fact family, when we work backwards, 4 times 2 should equal 8. 4 times 2 equals 8. Now, one thing we also is that multiplication is nothing more than repeated addition. So if I add 2 4 times, we should equal 8, which is the total amount that we started before we divided it up to the 4 trucks. So we know our problem checks. Now that was a pretty simple problem. Let's try a problem that's just a little more challenging. This time we're going to have 5 tons of gravel is equally divided between the same 4 dump trucks. Let's see how much gravel is in one dump truck. First, we're going to model the problem. First, we start with a tape diagram with our 4 equally divided trucks. We're going to label it as far as the total amount that we're going to be dividing, and in this case, it's 5 tons, looking for the amount in each truck. Now, when we write our division, we can see that it's 5 divided by 4 equals. When you're looking at the horizontal format, it's hard to see it. But if you look at the fraction that we've been working with, we know that 5/4, 4 going to 5 one time, with 1/4 left over. So our answer is 1 1/4. So 5/4 equals 4 going to 5 one time for 1 whole, and there's 1/4 left over. Now you can see for each sentence how the answer is now 1 1/4. So let's come back up to this one here for a second. And that's what we're going to use to check our work. So let me come up, and we got 5 divided by 4 equals 1 1/4. So we know 4 times 1 1/4 has to equal 5. To check our work, we know that repeated addition, all we have to do is add 1 1/4 5 times. Well, I like doing the whole numbers first. If I add the 4 whole numbers, I get 4. Leaves me with the 4 fractions, which is 1/4 plus 1/4 plus 1/4 plus 1/4,
When you're adding fractions with like denominators, the denominator stays the same, and you add the numerator. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, so we end up with 4 fourths, which is equal to 1 whole.
We add the whole number, sum, and the fractional sum.
4 plus 1 equals 5, which checks, because that's our total amount we started with.
Okay, that was our second problem. Let's try another one. This time, I've got a 3-meter ribbon and it is cut into 4 equal pieces to make flowers. What is the length of each piece? We draw our tape diagram. Once again, we have our 4 equal pieces. But this time, it's a 3-meter ribbon. And we're looking for how long 1 equal piece is. When we write our division sentence this time, we're going to have 3 divided by 4, because if you notice, our divisor is always going to be the one that we're splitting up equally. Our dividend is always the one that we're dividing, or our total amount.
Now this kind of is interesting here. When I look at 3 divided by 4, that doesn't make any sense. I can't divide 3 by 4. And this here it says 3/4 equals. Well, what does 3/4 equals? I don't know. Let's come over to this one here. 4 divided into 3. Well, if you think about it, 4 going to 3 is 0 times. And what's left? 3, or 3/4. So we come back over.
3/4 actually equals 3/4. Okay? And what's unique about this is any time our dividend is smaller than our divisor, our answer is a ratio right here of our dividend over our divisor. So 3 divided by 4 equals 3/4. It always works like that. So now we can say that each one of our 4 ribbon pieces are now 3/4 of a meter each. Now let's check this one. Since we know 3 times 4, 3 divided by 4 equals 3/4, so we know going backwards 3/4
times 4 has to equal 3.
Using our repeated addition, we know 3/4 plus 3/4 plus 3/4 plus 3/4, because we're going to do it 4 times, equals common denominator stays 4. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, equals 12/4. We know equals 3. And we can see that is what we started with, so our problem checks. Let's try one more. 14 gallons of water is used to completely fill 3 fish tanks. If each tank holds the same amount of water, how many gallons will each tank hold? Let's draw a diagram. Here we have our 3 fish tanks
and our total amount of water we're going to fill them with, and we're looking for how much in each tank.
Now our division sentence,
we all know that what we're dividing by is 3 fish tanks.
It's going to be 14 gallons
divided into 3 fish tanks equally, equals this.
Once again, if I'm looking at 14 divided by 3, it doesn't look that easy. But I come up to here and I say 3. Well, I know 3 are going to 14 4 times, because 3 times 4 is 12. And there'll be 2 left over. 3, 4, and 2/3, because 3 times 4 is 12, plus 2 would be 14. Now let's check it. Since 14 divided by 3 equals 4 2/3, so working backwards, 4 2/3 times 3 has to equal 14. Now let's go to our repeated addition, and we're going to add 4 2/3 3 times, so 4 2/3 plus 4 2/3 plus 4 2/3. Numbers first, I get 4, 8, 12. Adding my fractions, same denominator, stays the same.
2 plus 2 is 4, plus 2 equals 6. 6/3 equal 2.
When I add my sum from my whole numbers and my fractions, I get 12 plus 2 equals 14, which is what we started with. Now we've used, in this example here, this is what was on the sheet for us to work on.
is showing the multiplication sentence 1 divided by 3. And what you're doing is you're making a tape diagram of it. The 3 being our divisor, so that's what we're going to separate it into evenly. 1 is what we're dividing by. And this is saying 3 units equals 1 whole. I'm talking about this whole. And 1 unit here equals 1 whole divided by 3, or 1/3. And if you were listening earlier, when our dividend is smaller than our divisor, we know our answer is automatically 1/3, or 1/3, because it's 1 divided by 3. Now for our check over here, it says 3 times 1/3, so we're going to add 1/3 3 times.
The denominator being 3, 1 plus 1 is 2, plus 1 is 3, 3/3 equals 1,
and it checks. What you're supposed to do now is complete the last 4. I hope you understand and have a whole better understanding of using models to divide fractions.